Hi guys, this is the second video on the financial terms needed for project managers. In the first video, we looked at the present value and the net present value. We are going to continue from that discussion. The link to that file is down in the descriptions, along with the link to the file that you could just download and follow through in my just following my video. So assume that there's a project and the project has this cash flow. Initially, you'll have to just spend $40,000, and then it has a certain amount of cash flows in the next 5 years. Assuming that the discount rate is 10%, which is set by the economic conditions or the market, and we want to figure out what the net present value is, and we could simply use the NPV formula, but the initial value is not included that formula. So we'll just use that plus the NPV function in Excel, and the rate is going to be 10% along with this, the first year to the fifth year returns in the cash flow values. And in that case, the net present value happens to be 5,716 because it is a positive value, so that this project is worth to continue and select. And if there is another project then has like higher NPV, maybe you could just prefer that project over this one. But it's okay to also tackle this project if you have this initial investment amount of $40,000. Now, a lot of times the discount rate is the rate of return that is set by the markets is not very easy to determine, right? It could be 10%, it could be 9%, 12%, and in the future it may be different. So you may want to see for different discount rates what would happen to your net present value. To do that, we are going to use Excel's data table feature, and this is the table we created. What we do is we are going to just create a reference for the net present values, and because Excel was able to calculate the net present value here, so we are going to just say that, hey, this is the net present value, one example of calculation, and using 10% you were able to find this number. So let's try some other numbers. So this is kind of a sensitivity analysis, and it is going to try different rates, and the discount rates, it is going to calculate the net present value for those discount rates. And so to do that, we will just take this, the reference cell plus the other one. Do not highlight the title bar. So then Control Shift and down arrow will just 2 times is going to just highlight the table for you. Then you'll go to Data tab and What If Analysis and Data Table. And all these rates, different rates, are provided in a column, and they are a different value for, so a sensitivity analysis for this discount rate. So that we're going to just select on that range. So what Excel is going to do is it's going to just try all these numbers in place of this value behind the scenes, and it's going to create the net present value for that. So as you can see here, then we are now able to see the net present value for different rates, and we can just maybe look at this in a graph. So now I'm going to highlight the titles as well. We'll go to Insert and create a scatter chart. And now we are seeing that the net present value over the changing discount rates, and we are seeing that if the discount rate is larger than a certain number, then the project is not going to worth to try or just to continue. But if it is less than that number, then it is, right? So there is a decision point here. So how can we find that number? In that number here, you're seeing that the net present value becomes 0. So how can we make this value 0? By changing the discount rate. So we'll rely on another tool in Excel, which is going to be the What If Analysis and Goal Seek. So in the Goal Seek, we are going to set a value, a cell, then here, the net present value, and we want that number to be 0. So by changing the discount rate, and by doing that, Excel is going to change the discount rate and try to make this NPV 0 by using this numerical optimization, and it is going to just convert that number 0, and by just moving the discount rate. So when we do this, click OK, we are able to see that the discount rate is 14.2%. It makes sense, like it's less than 20%. It's somewhere here. So that 14.2% is called the internal rate of return. That's another decision criteria that you could use instead of the net present value. So if your discount rate is lower than 14.2%, then the project is going to create a positive net present value. So it's going to be a project that you want to do. And if the net present value is, this discount rate is larger than 14.2%, then the net present value is going to be a negative value. Let's just try this. Okay, so I'm going to make 20%, it's a negative number, and 10%, it's going to be a positive number, right? So and then I would be able to find those numbers as well. So in Excel is going to be able to find this for us instead of us finding that number. So using the goal seek, just trying to make the 0 and changing the cell of the discount rate, we can find this by using Excel's IRR formula, so internal rate of return formula, and then the values are all these numbers, and then just close it, enter. So it's 14%, and just increase the accuracy, 14.2%. So that is the IRR value, but there is one small issue. So let's take a look at that in the next worksheet here. We'll just do the same exact thing. So this discount rate and the NPV, let's just try this, and maybe we could just calculate this, just copy this to and paste on top of this. And with a 10% discount rate, then IRR is 10.5% calculated by Excel, and the NPV is negative value. So the 10% discount rate, then this specific project is not competitive enough to be chosen, and it's going to result in a negative net present value. So let's just try again the chart here. So the NPV value there, and we'll highlight this range again, and we'll go to the data tab again, and what if analysis and data table. So this is a column input again, and the discount rate. Okay, now we are going to just create the chart again. And we are seeing something different. What we are seeing here is that we are not just seeing one, the internal rate of return, but we are seeing two internal rate of returns, IRR values. And because at these 2 points, the internal rate of return makes the net present value 0. We are going to be able to find these two numbers. Excel was able to find one of them, but Excel did not find the other. So we could try in the guess part of this. So there is the guess, and we could just maybe try something like closer to 1, like 0.8 or something like that. And then it gives us that 82.3%. So we are trying to let Excel know that it's not close to the 0, it's close to that 1 area. But do we have to look at this and just consider these two values? Because we have now the computational power and then we have a graph, actually we can just make a better decision by just looking at the figure instead of just looking at the NPV or the IRR like as individual values, or the NPV for a specific discount rate. We can just say that between these 2 points, that the net present value is positive. So as long as the discount rate stays in that range, if we believe that that is going to happen, then the project is going to return a positive net present value. So this is a valuable information. So you do not just need to look at an IRR value. You could take a look at this as a graph and understand this. The whole range starting from this part to that part is going to be okay to, if the discount rate is in that range, if we believe that, then the project is can be chosen and can be implemented. So let's say we are not able to find this internal rate of return. By doing that, what we could also do is that we can go to the data tab and the solver. And to activate the solver in your Excel, so you'll go to File and then Options and your add-ins and then Excel add-ins, and go and just check the solver add-in. And this is for PCs, and for Mac computers you could look at Google and just try to see how you activate the Excel solver. So I'm going to go to the solver and I'll say, okay, you know what, I'm going to make the NPV, and that's my objective. I want to set it as a value of 0. So by changing variable, and that's the discount rate, and I'm going to first try and maybe add a constraint and saying that I want that discount rate to be, let's say, less than 0.3, and 0.2 doesn't matter, and click OK. Then we click solve, and I'm able to find that that's 10.5, and I can do that again. Now instead of making that less than 0.3, I can change that and make it greater than 0.3, and just change it and solve it. Now it is giving me that discount rate to be 82.3. So both of them are the internal rate of returns, and between these two numbers, if the discount rate stays in that range, so the project is going to be can be chosen. Now we're going to move on to the next possibility, where there is not a single project, but there are multiple projects, and I just chose these 2 projects instead of just choosing some other numbers. And I will just look at the NPV and calculate the internal rate of return values. And by doing this, let's just only look at the NPV values. Okay, so let's just do it here. So the NPV is going to be, the rate is 10%. I'll put a $sign on the column because I want to copy this across to the other column, and I don't want to change the discount rate to go to another cell. And then the values are these values, and close it. I'm sorry, I think I just made a mistake. It's going to be B3, and it has to be this value plus. Okay, so the initial value plus the net present value of the future cash flows. So that's 5,716, and then I copy that. This is negative 299 for 10%. And then I can maybe ask Excel to guess those. And that's going to be all of these. And this 14%, and this is 11%. Okay, so here, if I know that with a certainty that the discount rate is going to be 10%, then the net present value gives the higher value for the project 1, then I would choose that project. And otherwise, this is project number 2. I copied and pasted. Okay, so now, but what happens if you want to see the big picture, right? So we don't need to just rely on our financial calculators. We can just use Excel to just see the big picture here. And then I'm going to just do the same thing for different rates. I'm going to look at the first net present value. That's my reference here. And then this is my second one, and that's the reference. And I want to create my data table again for these. And then I'll go to my data and modif analysis data table. And this is again, what I'm changing here is the rates, and they are in a column. and it's a column input, and they represent the single discount rate. And click OK. Then I'm able to find the for different rates, the two net present values for two different projects. So let's just highlight this and then create our chart. And I'm going to go to the scatter chart and click on this. And you can consider this as maybe put a title here, comparing the net present values of different projects given different discount rates or something like that. And then this is our sensitivity analysis for this two project comparison process. And then I want to look at this chart. Why did I hide this chart? Come back here. Okay, here we go. And what we are seeing here is that I don't want to see right now that 80% range. It's very, maybe unlikely that the discount rate to be around 80%. Like which investment or like which economic conditions are just giving you 80% return every year, right? So that's going to be like difficult to see. And unless it's a Ponzi scheme or something like that. Okay, let's just click on this axis and then format the axis here. And then I want to look at the range only like in this 0 to, let's say, 0.2. I think that those are going to be my bounds. 0 to 0.2. And then I have my chart. So here we go. What we have is we have the from 0 to 0.2. We can also do this. Let's just do it in here instead of from there in the chart. I'm going to start from 0% to 0.2% and just change these rates and go up to where? 3.40. I think that's sufficient enough. Let's just create the chart for this and insert my scatter chart. Oh, why did I not think about that? So let's it's going to about, oh, okay, 3.4%. We don't want to just do that. It's just keep that scatter chart, guys. And then I'm going to just make that instead of 0.2, let's say 0.5 or 0.5, yeah. So 0 to 0.5. Okay, that doesn't work. What's happening? Okay, 0 to let's say 8. Okay, good work. Why do I make this 1.5%? 1.5%. Okay, 0 to 1.5%. Here we go. Okay, I'm not sure why I was doing here there, some brain fart. Okay, so what we are seeing here is that we are seeing which project has a higher NPV in what range, and also we are able to see their IRR values, the rate of internal rate of returns, and here this is for the first project, and that's about 14%, right? And the other one is 10%, and this one has another IRR value in the higher end, but we would just want to focus on this part. So we can just make a decision criteria. If the discount rate is going to be less than, around, like this is 14%, so it's going to be somewhere around 13%. We'll calculate that. Then we would just choose this one. The blue one has a higher net present value, so the project one is better. If not, then the project 2 is better. So at this point, these two lines intersect, and it may be a good idea to find that line as well, how they intersect. And then the intersection point is the POI, the point of indifference. And the point of indifference between these two values is, let's just find that out. And at what point their net present values are equal to each other, right? And if they are equal to each other, then their difference is going to be 0. So B10 minus C10. it's this value, then we'll just go to data and what if analysis and goal seek. We want this number to be 0 by changing the discount rate. Click OK, and we are able to find that exact point, and that's 13.1%. So if the discount rate is believed to be less than 13.1%, so then the better project is going to be project 1. Otherwise, the better project is going to be project 2. And that's the end of the discussion. Thanks for watching.